presentation of how we were able to train tiny LLMs in order to perform really specific tasks super efficiently and super easily for free using just our Macs. So the problem, the main challenge that we're facing is that training AI is super expensive and also super complicated, right? Most of us, we don't have the required infrastructure to have these GPUs. We can't buy them because they're way too expensive. We can potentially rent them, which is something that I did at the very beginning. And even doing this is fairly expensive. It's not only renting the GPUs, but also configuring everything around it, making sure that we have the correct CUDA drivers that work correctly with our libraries, that work correctly with the models that we're trying to train. This is all really a cumbersome process, which can take hours to get started. And at the very beginning, it took me even days to figure everything out and learn how everything works. And even then, after doing all of this, we end up with a model that's really expensive to run, really complicated to run. So I have to host the model on a cloud GPU, which leads to really high monthly costs as well. So this is basically just something we can't do if we can just solve a really narrow specific task, right? Well, that's what I thought. But thing is that since a couple of years ago, 5 or so years ago, Apple really started to release Macs with a unified RAM. This means that basically all of your system RAM on your Mac is also your video RAM. This means that basically we have really fast RAM in our Macs. And this means that all of the RAM available on your computer can be used to train and run inference on LLMs. To improve this and to be really good at doing these specific processes, Apple also work on the MLX framework, which is basically the same APIs that you would usually use to interact and train models, but they are native for Apple's graphics API, which is called Metal. And finally, and the last thing of the puzzle, this is an even more traditional thing that we have even for longer. Nowadays, we don't need to train whole models from scratch. We don't need to retrain a full model in order to adapt it to our use case. We can do low rank adaptations or LoRAs, where we train a really small amount of the model, really small amount of the parameters to get really good results. This is even better if you have a really small data set, because usually if you have a really small data set and you train a model from scratch, then the model would forget how to do most things. But here, because we're only training a really small amount of the model to do a really specific task, all of the other parameters still quote unquote remember what they are supposed to be doing. So the model still performs really well in general at the other things related to perform this task. So this was the result that we had. I wanted to train a model that would basically help my transcription process to eliminate self-corrections. So if I say, hey, the meeting is going to be at 5, oh no, sorry, it's going to be at 6, I wanted the model to just fix this and just tell me the meeting is going to be at 6. So I tried a really small base model that I could just run inference on my Mac, and it was horrible at this task. We tried with tons of different prompts, and it basically either completely gave us the same output, so it just echoed the input, or it rewrote it very creatively, which wasn't what we wanted either. After doing this fine-tuning and this process, we ended up with 12 out of 12 in our really small evaluation, so the model was really good at performing the task that we wanted it to perform. And how do we do this? Well, we did distillation from a bigger model, which is something that's really popular nowadays. But we were able to do it with a really cheap model because this was a really narrow task and with a really small data set. So we had Gemini Flash create training pairs. Then we validated the result with the same prompt that we give Gemini to our model, just to have this baseline evaluation. Then we formatted the output to be the proper JSON-L format to do the training. Then we perform the training, directly on our Macs. And finally, we fused the adaptator with the model to create a new model, and we deployed that model to Hugging Face. And this was the result. The student ended up being better than the teacher. Basically, Gemini was able to perform the tasks correctly in 11 out of 12 evaluations, and our fine-tuned model was able to perform all of them correctly. This is mostly because the data that we used to train, to fine-tune our model that was created by Gemini itself had a really clear boundary of the task of what needed to be performed. So it was able to, with this really consistent training data, train to learn how to perform these tasks super effectively versus Gemini, which has a much wider set of tasks that I need to do. When it was given a different input than the one that was on the training data, it wasn't as sure of how it needed to perform the task. Here what I'm trying to say is that it's much easier for you to pass your own exam rather than an external exam. So Gemini was super good at building their own exams and perfect answers for those exams, but when I gave it my own, it wasn't as good at performing the task. But because we had a really good set of exams, our model was able to learn from those exams and ended up being better at performing our specific task. And this doesn't work only, this is not only for text. We're now trying to do this for vision models too. The process ends up being really similar. We generate synthetic images. We generated these ones with using Gemini as well. We used Gemini 3.1 Pro image generation, also known as Nano Banana 2. And it was pretty complicated it's a much slower process for Gemini to do this part. And we were able to we iterated a lot on the prompt for this as well, and we're still on the process of getting the results for our vision model training. This is because we had some problems. We weren't able to use directly MLX to train the vision parts of our model, so we had to do a fallback on PyTorch, which is a lot slower, but we can also do on our Macs. It also consumes a lot more resources. And basically we tried to create a model that was able to see an image, understand the names, emails, specific words that were going to be able to give really good context to our transcriber. So for example, if the user is in some medical terminology, sending an email to a person that's talking about a specific disease, when I use my transcriber, I wanted to be able to pick up the disease, the email, the name of the person that is talking to 100% of the time. And in order to do this, I basically have this model take a screenshot of the computer. I extract those keywords, and it needs to be really good at extracting those keywords and not the rest of the information that's on the screen, right? So we're training a model just to do that. What would this look like if we wanted to run this in our machine, in the via inference? Well, we could either we could train a model, which we already gone super expensive. I could already explain why, and host it in a cloud GPU. It would pay a fuck ton of money. We could also just take advantage of the subsidized inference that all of these API providers do. So I could run this also on just Gemini 3, and it would still be fairly expensive. Just for a single user, we're talking about $30 to $300 a month for the current usage that I'm doing. And just fine-tuning it on my Mac and running it on my Mac, it's free forever. And yeah, why and how can we do this now? Well, Apple Silicon released in 2022 with the unified memory that we talked about. MLX and LoRa was released just 1 year later. And in 2025, we're starting to see now models that are just 0.8 billion parameters that rival what 7 billion parameter models did 2 years ago. So a model that's 10 times smaller is performing at the same level that it was just a couple of years ago. Funny enough, this is this effect is much bigger, and this multiplier gets much bigger as we get bigger and bigger models. And I imagine in a few years, computers and devices will have enough RAM when this hype cycle stops. Devices will start having way more RAM, which will allow us to run these bigger models, which will have even bigger multipliers. And yeah, what type of things can we build with these tiny models in our space? Well, we can build dictation cleanup, which we did. We can build translation post edits to fix specific domain issues. We can build email classifiers, data extractors, medical note cleanups, document summarizers, basically really narrowly defined tasks. That's the key that I want to get across here. LLMs are really good at generalist tasks, but the breakthrough here is that we can do really narrow tasks even better in some cases for free. And I'm finally going to leave you with 5 things that I learned that I wish I had learned earlier, that wasted some time for me. First and foremost, whenever you start trying to do these tasks, start trying to tweak the prompt. Just trying to tweak the prompt had a huge impact for us at the very beginning. There are many frameworks that you can use in order to automate this. You can also just leave Cloud Code on a loop. It's pretty good at it itself. Teacher validation is better than the raw generation that you can do yourself. The same prompt using for train and inference, it turns out that the teacher models are much better at creating these exams and passing these exams for themselves. So even though you may think that the model is not good enough to perform this task, a bigger model, and the teacher model may be not good enough in order to do this, we were able to use a flash model, which is not a top tier model. It's a fairly cheap model, and we were able to create a really good data set that ended up outperforming itself. Finally, small models beat large models on many narrow tasks. At the very beginning, I started thinking, well, how much RAM do I have? How do I train? What's the biggest model that I can train? How can I train the most of its parameters? And that's probably the best approach if you're trying to beat state of the art, but that's not realistic of what we can do with our computers, right? You can probably do it, and you can probably beat state of the art. It's surprisingly easier than it looks like, and it's a really fun challenge if you want to do it. But you do need external GPUs, and you're going to need bigger models. And for most of the tasks that we're talking about today, you should be using smaller models, starting with smaller models. And this is really related to our point 5 here. We'll get to it later, but basically you want to fail early, because failing early is how you learn, and failing early is how you waste less time and less compute. Smaller models help you do that, and once you have a smaller model and you can see that that smaller model is getting way better at the task, then I would recommend go for bigger models if you want. Number 4 here is that when one framework fails, this doesn't mean that it's not going to work on your machine. You can try different frameworks. They're going to be slower, but don't forcing yourself to use MLX is not always the best option, right? There are really smart people working in all of these technologies. There are super smart people working on trying to get everything around MLX working. If something doesn't work, you don't need to give up, but you also don't need to fix MLX. You can just switch to use a different framework in order to do the rest of the tasks that you want to do. And finally, do small tests before running your scripts, right? Do a sanity checks of your output of what you're trying to do. Do a sanity check of your pipeline of your base generation. Do a sanity check of your gold standard process. Do a sanity check of your training process. This is going to save you hours. Basically, you want to see the output before running the whole thing. And yeah, this is everything. Just wanted to say you should give this a go. You can stop renting your GPUs. You can start training on your Mac. You have You can get to my repositories to have some resources on how I did this, and I'm publishing my models little by little directly on Hugging Face. They are all completely free to use, and all of my documentation is fully MIT. So yeah, I hope you like this presentation.